All right, we're looking at lesson 6-3 on page 148. Improper fractions and mixed numbers. All right, so how can you represent quantities that are greater than or equal to 1? Jenny and Tyler are baking bread. How do the measurements that they make relate to fractions and mixed numbers? All right, so let's look at the fractions that they have. They have 4.5 cups of flour. So there you see the 4 and then the half here. They have 1/2 cup of sugar, and then they have 4/3 cup of milk. All right, let's look at the next page. Okay, so let's look at these numbers on a number line, and you're going to need to take some notes because you have some vocab here. A proper fraction first. So we're looking at the 1/2 cup of sugar. So a proper fraction is less than 1. Okay, it equals something less than 1. And to show that, you would know that its numerator is less than its denominator, like in 1/2. 1 is less than 2. Top number is always less than the bottom number in a proper fraction. Here's an example of an improper fraction here. In the recipe, it called for 4/3 cups of milk. So an improper fraction, here, let me make it so you can see that. An improper fraction is greater than or equal to 1. So in this case, you'll know an improper fraction because its numerator is greater than or equal to its denominator. So it could also be 3/3, which would be, 1 whole right there. So any time that the numerator is equal to the denominator or greater than, you have an improper fraction. Make sure you pause me and write down these definitions if you need to. And then last we have a mixed number. Now think of the word, it's mixed. So it combines whole numbers and a fraction. Like in the case of the flour. They have 4 whole cups of flour and another 1/2 cup of flour. So 4.5 cups of flour. So we have proper fractions where the numerator is always less than the denominator. Improper fractions where the numerator is equal to or greater than the denominator, and we have mixed numbers, and they combine a whole number and a fraction. Okay, look back on page 148 at another example. This lesson really is trying to teach you how you can change improper fractions into mixed numbers or mixed numbers back into improper fractions. So they have the first example over here. I've got 12/9, and they want to change this improper fraction to a mixed number. In order to do that, you need to divide the numerator by the denominator. Remember how we said a fraction could be written as a division problem, and it's always the top number, here we are in the box, 12, divided by, outside of that, the 9. So, and if you think about it, like try and get a mental picture. Remember, our fraction, the denominator tells us how many total pieces it takes to make a whole. So in 12/9, it takes 9 pieces to make 1 whole. And I have 12. So you're trying to figure out how many whole numbers you have, and it takes 9 to make a set if I have 12. So they divide 12 by 9, and you know that 9 goes into 12 one time. So I could make 1 whole set. And I would be left with 3 pieces. So your answer becomes 1 whole. Let me erase this here. 1 whole, and then the remainder are your pieces, so it becomes your new numerator, and you can put over 9 because we don't change our numerator. It was 9ths, and it still becomes 9. So 1 whole and 3/9. But like they show you down here, 3/9 is not in simplest form. We can divide by 3/3, which would give us 1 and then 1/3. Now if you think about it, I want this to make sense. So again, you have these 12 pieces. Think of this 12/9 again. You have these 12 pieces, and it takes 9 to make 1 whole. So if you had, 12 little circles to make, your set, and 9 of those pieces would make 1 whole. You could then say, well, I'm going to take my 1 whole, right? And how many pieces do I have left? I have these 3 pieces left, and it still takes my 9 to make 1 whole. And I would then, of course, make that a simpler, and write it in simplest form, which would make your 1 and 1/3. Make sure you're taking notes on this. Alright, so I'm going to clear the screen. You can always back up if you need to. Maybe. Alright, there we go. So now let's look at the opposite. Let's say now we want to go from our mixed number to an improper fraction, the opposite. Alright, so again, look at 3 and 5/8, and let's think about this number. What this number is telling me is I have 3 whole sets, and then I have 5 pieces out of 8 sets, because how many does it take to make a whole in 3 and 5/8? 8. 8 pieces to make 1 whole. So what you're going to look at is you're going to look at this and say, well, you could say I have 3 whole, and here's my 5/8. Well, if it takes 8 to make 1 whole, then I have, I'm going to do it like this, 3 times 8, which would give you the 24 that they show here. And then you want to add the pieces that you have up at the top. And I have 5 more pieces. 24 plus 5 would give me my 29, and you still keep the same denominator. So again, basically what you're doing is you're taking your whole number, you're multiplying it times your denominator, here 3 times 8, and then you're adding your numerator to that. Okay, I wrote a couple examples of mixed numbers, and I'd like you to pause me and see if you can try to write them as improper, and then hit play and see if you get it right. Okay, so in the first one I have 2 and 4/5. So again, it takes 5 pieces to make 1 whole. And I have 2 of those. So what I would do is I would multiply, put my little X there, 2 times 5 to get 10. I'll write this up here if you want to write it like that, you don't have to, plus my 4 pieces that I already had. And that's all, oops, I can't, not over 8, that was the last one, all over that same denominator, 5. So what I end up with is 2 times 5, which is 10, plus 4 is 14 fifths. So 2 and 4/5 is equal to 4/15. Now, you can write it this way again if you want to, but I prefer to just put my little signs in here. So number 2 is 5 and 7/8. If I wanted to see what that was as an improper fraction, I would say, okay, I have 8 pieces that make each whole. So, and I have 5 whole sets. So I'm going to multiply 5 times 8 to get 40. And then I'm going to add that those 7 pieces to it. So I know I have 47 pieces, and it still takes 8 pieces to make 1 whole. Alright, let's look at changing improper to mixed. Again, I have a 4 as a denominator, so I know it takes 4 pieces to make the whole. And I want to see how many 4s I have in 10. So I can go ahead and say, well, what is 10 divided by 4? Remember, this fraction is a division problem. 10 inside the box being divided by 4 outside of the box. 4 goes into 10 2 times, which would give me 8. So I know it goes into it 2 times. I have 2 whole sets if it takes 4 to make a set, and I have 10. And then I have these 2 pieces left, so you can go ahead and just make that your fraction, put your 4 as your denominator again. So I have 10/4 equals 2, and 2/4, which all of you know, since 2 is half of 4, that it would be actually written in simplest form, 2 and 1/2. Alright, try number 4, pause it. 15/6. Alright, think about this again. It takes 6 to make 1 whole set, and I have 15 pieces. So I'm going to divide it and say, well, how many sixes are, or how many sets of 6 are in 15? Well, we'd go into it 2 whole times, which would give me 12, and I'd be left with 3 pieces, my remainder. So again, I could put those 3 over 6 because that's the portion I have left, and this is my whole number up here. Oh, look at that. I did the same thing. So I have 2 whole and 3 6, which would again be 2 1/2. You won't get 2 1/2 all the time. Okay, this is what I'd like you to do. Go ahead and do 1 through 5. 1, 2, and 3 are improper. You're changing those to a mixed number in simplest form. And then I went ahead and put 4 and 5 up there because I'd like you to try to go the opposite direction and change a mixed number back into an improper fraction. And bring that to class tomorrow with a question. See you then.